Hello and welcome to this video on Team 18's senior project to design and build an electric scooter alternative. This project is sponsored by TNT Tools. This video will give a high-level description of the project and will cover problem statement, specifications, prototyping, the scooter design process, mechanical simulation, electrical components, the final product, and finally, challenges of the project. To begin, the goal of this senior project is to design and build a stable, lightweight, and electric scooter alternative to be used within an urban environment. Let's take a look at specifications. Beginning with the electrical specifications, we have that the scooter is to be powered by a lithium-ion battery. This battery is to be monitored to ensure safe operation and usage. To turn on the scooter, a physical on-off switch is to be used. Alongside this, a safety kill switch is to be implemented to ensure that the scooter cannot be powered if the kill switch becomes active. To propel the scooter, a single in-hub BLDC motor is to be used. Moving on to dimensional specifications, we have that the scooter is to weigh less than 40 pounds. The scooter should also be able to fit within a 12 by 20 by 42 inch space when folded, and should also be able to move an operator of at least 250 pounds. The following specifications govern how an operator is able to interact with the scooter. First, we have that the scooter shall have a platform on which the operator can stand. The scooter shall also have a collapsible T-handlebar. It should stand on 3 wheels, and acceleration is to be controlled via thumb throttle. The turn radius of the scooter will not exceed 7 feet. And finally, LED indicators shall be used to indicate battery charge level to the operator. Moving on from specifications, we'll talk about prototyping. The goal of our prototypes was to determine the best method of steering. First, on the left, we have truck steering, which is a common method of steering by leaning found on longboards and such. Second, on the right, we have the typical linkage steering found in many vehicles. It was found from the truck steering prototype that this method would provide poor stability and would have too large a turn radius. The steering linkage prototype was made using a modified Knee Rover scooter that already incorporated a linkage system. Testing gave the desired stability and turn radius, and as such, this steering method was selected for the final product. Next up, we have the scooter design. The current steering linkage system mimics that of the setup found on the Knee Rover prototype. The steering handle was purchased as is from Roadrunner Scooters, a company based out of Colorado. User controls such as the throttle and brake clamp onto the handle's tubing. To make the handle collapsible, a folding mechanism is designed to integrate the steering handle piece to the rest of the scooter, while also giving it the folding capability. The frame of this scooter is made of tubing. The skid plate is designed to fit beneath the frame to protect electrical components that are kept beneath the platform. Steering stops are incorporated to limit how sharply the 2 front steering wheels can be turned for better control. The in-hub motor is mounted in the rear using specially designed motor mounts. The rear fender incorporates a restraint for the T handlebar to keep it from turning when properly collapsed and folded. A rear handle is also mounted to allow the scooter to be towed similarly to a dolly when folded up. Next we have simulation. FEA is performed to ensure the weight-bearing components do not fail under the rated load as covered in the specifications. Moving on to electrical components, we begin with the rear in-hub motor. This motor is rated at 500 watts and 48 volts. It has an 8-inch diameter, carefully chosen for stability and comfort of the overall system. The chosen motor controller comes from Kelly Controls Incorporated. It is rated for handling 48 volts and a continuous current of 25 amps. The battery to be used is thus rated for a nominal voltage of 48 volts. It also has a 10.5 amp hour capacity and can discharge a peak current of 50 amps. In addition to the battery source itself, the module has a BMS integrated to provide the desired battery monitoring. An IEC C14 charge port will be wired to the battery to use for charging. The safety kill switch used for the scooter is commonly found on ATVs. They are meant to disable operation of the vehicle in the event the operator is thrown from the vehicle. The thumb throttle and battery charge level indicator come in one compact package to save real estate on the T handlebar. The throttle sends a 1 to 4 volt signal to the motor controller, which then adjusts the speed of the in-hub motor accordingly. The implemented on-off rocker switch shown here. It simply controls the power state of the motor controller. Now then, please enjoy these 2 short videos of the scooter in action. Please note that for these demonstrations, a test battery was used in place of the final battery, which had yet to arrive.
But it's not too bad. Whoever wants it. I mean, it's pretty. I mean, the big thing is like if you are turning one way,
Sorry
and you're leaning that way, and all of a sudden you turn the other way, like it will tip up.
Okay.
So it's like just try to stay semi-center, and you can play with like your feet. Like if you're doing a sharp turn, just
Okay.
it's like a feel thing.
Yeah.
You'll
This is the brake.
yeah, so probably just keep a finger on that all the time, just to sit. Yep. Yeah, you just push that down. And
Perfect. Yeah. Goes up to like
yeah.
Once you ride it,
Yeah, I'm sure after you do it.
As mentioned before, the collapsible folding nature of the scooter and the rear handle allow it to be transported easily as a dolly. The scooter's compact size also allows it to fit nicely in most storage spaces, such as a car trunk, bus storage, and similar. Here we have the scooter on display. Note that at the time of this video, the scooter still needs to have the frame powder coated, have the final battery delivered and installed, and have the wood platform treated. One main challenge of this project has been keeping the weight of the scooter within specifications. In the end, the shown final product came out to be 42 pounds as opposed to the desired 40 pounds. However, the sponsor determined that this aspect is acceptable and generously agreed to sign off on this specification. Aside from this, the other main issue has been dealing with supply chain lead times. At the time of this video, we've yet to receive our final battery and some other non-vital mechanical components. This concludes Team 18 Senior Project presentation. We hope you've enjoyed this video, and thank you for your time.